Welcome to all for today's video session about heat transfer radiation and concept of black body radiation. So first we know that what is meant by concept of black body radiation. In radiation, heat transfer of a black body is an idealized physical object that absorbs all incident electrophenomenon regardless of wavelength or angle incidence. The concept of black body is a fundamental in thermal radiation and perfect emitter and absorber of radiation. And the key characteristic of a black body is the black body absorbs 100% of the radiation that strikes it. It reflects and transmits no radiation, so it appears completely black when cold. And perfect emitter, a black body also emits radiation at the maximum possible intensity for any given temperature. This radiation is dependent only on its temperature and not its material or surface properties. And the concept of black body also focuses on the laws of Planck's law. So the distribution of radiation emitted by a black body is described like black body relates the intensity of radiation to the frequency and the temperature of the body. So Wien's displacement law, it states that the wavelength at which emission of a black body and its maximum inversely proportional to the temperature. And Stephen Boltzmann law, the total energy radiated per unit surface area, black body per unit time, also called black body radiation, is proportional to the fourth power of the black body absolute temperature. And this image will represent about the concept of a black body. And this graph is drawing between the wavelength and power density of the concept. So this is the radiation power density is in visible is a 3000 Kelvin and 4000 Kelvin, 5000 Kelvin and 6000 Kelvin temperature regarding the power intensity to the wavelength. So the radiated power density Planck law is proportional and to the concept of the Wien's displacement law. Previously, I was example and quoted that. So we know already to know that heat transfer is a mode is divided into the conduction, convection, and radiation part. In conduction, is the heat transfer is traveling between the heat traveling between the solid surfaces, and the convection part is the heat transfer is traveling between the solid and liquid part else thing. But here is the important is we focused is then radiation part. So the radiation is conversely the heat transfer or radiation heat transfer will occur between the electromagnetic wave phenomena. So this is the heat transfer of a black body radiation supportive. And application of the radiation heat transfer is astrophysics and used in engineering concepts and climate science concept. And astrophysics, stars and other celestial bodies are often modulated as black bodies to estimate the temperature and radiation output. And engineering, it understanding the black body radiation is crucial for designing systems that involve thermal energy transfers such as furnaces, heat exchangers, and radiative cooling systems. And climate science is also in the will be denoted in the application of the Earth and its atmosphere are modeled black bodies to estimate heat exchange with space. So these are the application will focused on the radiation heat transfer and concentrated into a black body concept. So in this class, I will hope that all are will know about the what are the fundamental laws in radiation and what are the concepts will be implemented in how to it will be worked in radiation phenomena, and finally the it will be how to relate with the application oriented part from the area of the radiation heat transfer. And I will conclude of this video session in revised from the key characteristics of black body and perfect emitter and Planck's law and wind displacement law and Stephen Boltzmann law and black body concept radiation is focusing upon the concept of a black body, and finally it will be goes or finally it will be converted into what are the applications will be implemented in radiation heat transfer and phenomenon of a technique. Thank you.